We usually describe aging as a series of mechanical failures, knees that give out or skin that loses its elasticity. But at the microscopic level, your body is actually suffering from an identity crisis. Inside your cells right now, 99% of the youthful genetic code you were born with remains perfectly intact. The DNA is the hardware, but your epigenome is the software. It uses chemical markers called methyl groups to act as instructions, clamping onto the DNA ladder to turn specific genes on or off. Over time, this software glitches. The markers detach and drift, meaning a cell that once knew exactly how to be a hair cell or a skin cell begins to lose its specific instructions. You possess the genetic blueprint to stay young. Your biological operating system is simply losing the ability to read the manual. Modern life accelerates this corruption. Every time you fly on an airplane or are hit by cosmic rays, your DNA strands physically snap. Routine medical X-rays and historical radiation exposure contribute to this steady accumulation of microscopic breaks. The physical snap is only the trigger. The aging process truly takes hold during the frantic cellular panic that erupts as the cell tries to survive the damage. Every stressor acts like a scratch on a vinyl record. The music is still there, but the skips make it impossible for the cell to play the beautiful symphony of its youth. This system is managed by sirtuins, protective conductor proteins that keep epigenetic markers organized. But when a chromosome snaps, they abandon their posts, rushing to seal the gap. Afterward, they scatter, leaving the cell's identity markers abandoned and jumbled. After decades of these molecular distractions, your cells face a terminal identity crisis. Skin cells begin acting like nerve cells, manifesting as the frailty and gray hair we associate with old age. This microscopic game of molecular musical chairs is the primary mechanical cause of aging in all living creatures. Sirtuins require a fuel molecule called NAD to function. In our modern world of constant comfort and abundant food, our natural NAD levels deplete, leaving our repair crews exhausted. We see the alternative in nature's longest living organisms. Ancient trees evolved robust repair systems, and deep-sea whales survive in harsh, predator-free environments that demand constant cellular resilience. We can trigger this survival mode through hormesis, subjecting our bodies to controlled adversity. Fasting, cold plunges, and intense breathless exercise trick the cell into producing more NAD to fight for survival. We can also utilize xenohormesis by consuming plants that were stressed during their own growth. The concentrated polyphenols in matcha or blueberries hyperactivate our sirtuins, acting like a chemical boost for our repair systems. By manufacturing disadversity, we force our microscopic software to hit the save button on our cellular identity. This theory is no longer confined to petri dishes. At Harvard, scientists have moved beyond just slowing this decay to actively reversing the clock in living subjects. Researchers are now using engineered viral packages to deliver 3 specific reprogramming genes directly into the optic nerve. Once activated, these genes reset the epigenetic clock by 75%, successfully curing blindness in primates by restoring the cells to their original, youthful state. These trials demonstrate that the biological software of youth is not lost, it is simply waiting to be reinstalled. This shifts our entire medical paradigm. We are now classifying aging as a universal root-level disease, a condition that can be managed and targeted like any other pathology. Reversing the age of our cells provides a cure for other ailments by default. Alzheimer's, cancer, and heart disease fail to manifest because youthful, reprogrammed bodies possess the innate ability to clear them away. Assuming we are destined to become frail at 80 is like looking at the first fragile flight at Kitty Hawk and assuming we would always be limited by the speed of a horse. Evolution only required us to survive long enough to race the next generation. We have outlived that requirement, and we now have the tools to bypass our original evolutionary limits. Resetting adult tissues on command allows us to treat the body as maintainable hardware. In this new era, the longevity of our consciousness depends not on a fixed biological clock, but on our ability to keep the system running.